So in this class, in my video we have no introduction, but it's alright, introduction is not always required. Till the previous class we studied about the components of vector, direction ratios, direction cosines, right? The unit vectors. Is it okay? Yeah. The types of vectors we have studied. Today we are going to study section formula in vectors. In class 10 and class 11 also you have studied section formula. Class 10 means only internal division. In class 11 you have studied both for internal and external division, right? You have one small chapter to 3D, no? In class 11 there you have studied. So we are going to apply section rule in vectors. So let's see how are we going to perform this. Okay. So first of all, let us see what is section formula. Section formula. Suppose there are 2 points. Let's say there are 2 points A and B. Coordinate of B is x1, y1, z1. Coordinate of B is x2, y2, and z2. This is in 3D, no? If you want to talk about 2D, then we can take only x and y components. Alright? Suppose R is a point on the line joining AB, which divides AB in the ratio m is to n. That means the ratio of these two parts is m is to n. Then that means R is on the line joining AB. R is in between AB. That means R divides AB internally in the ratio m is to n. So here R divides AB internally in the ratio m is to n. Then the coordinate of R can be determined by using the section formula. mx2 plus nx1 upon m plus n, right? my2 plus ny1 upon m plus n, mz2 plus nz1 upon m plus n. So if R divides the line joining AB internally in the ratio m is to n, then the coordinate of R can be determined by using this formula known as section formula. Clear? Now, that is for internal division. Again, let us say that this is your A, this is your B. Coordinate of A is x1, y1, z1. Coordinate of B is x2, y2, z2. Suppose R is outside the line AB. Okay? And let's say that R divides AB in the ratio. R divides AB in the ratio m is to n. In the ratio m is to n. Okay, here distances are not m and n, okay? Ratio is m is to n, alright? Okay. So in that case, in this case, R divides externally. R divides the line joining A and B externally in the ratio m is to n. Alright? Now, R divides the line joining A and B externally in the ratio m is to n. So R divides AB externally in the ratio m is to n. Then the coordinate of R can be determined by using the formula mx2 minus nx1 upon m minus n. All this can be proved. It can be proved, okay? But it's not necessary to prove this now, so I'm not proving. my2 minus ny1 upon m minus n, mz2 minus nz1 upon m minus n. This is the section formula for external division. Is it okay? So we are going to apply this section formula in vectors. In vectors means instead of finding the coordinate of r, we find position vector of r. Right? R may divide AB internally or externally, but we apply section formula not to find the coordinate of r, but to find the position vector of r. Alright? Yes, it's very simple. So if this is clear, I'll rub this out, and then we will go for the vector section formula in vector. In vector algebra. That will sound better, but in vectors. It's okay. So what is this again? Same old story. X-axis, y-axis, z-axis. So this is your 3D. Suppose this is your point A. This is your point B. Is it okay? Then if this is your point A, this is your point B, then what will happen? This is another vector AB, right? Directed from A to B, no? Let's say that R is any point on vector AB, no? R is any point on line AB. Okay, if you are having confusion with that, A is any point, B is any point. Okay? Let R be a point, be another point on the line joining A and B. Is it alright? Then see, such that R divides AB internally in the ratio m:n. Okay? Then what is this? What is this? Position vector of A, right? This is position vector of A. Position vector of A, let me denote by vector A. This is what? Position vector of B. Position vector of B, let me denote by vector B. Then we apply section formula to determine the position vector. Let the position vector of R be denoted by vector R. So here, R divides AB internally in the ratio m:n. Then by section formula, position vector of R will be given by what? Position vector of R will be given by m times B vector plus n times A vector upon m plus n. Where B vector is the position vector of B, A vector is the position vector of A. Correct? Yes. But if R divides AB externally, this is for internally. R divides AB internally in the ratio m:n. Okay? Yeah. Here AB can also be a vector. Okay, here AB also can be a vector. AB the vector below. Is it okay? Yes. So if R divides AB externally externally in the ratio m:n, in that case position vector of R will be given by m times vector B minus n times vector A upon m minus n. This is how we apply section formula in vector algebra. Is it alright? You can just note this down.